Alright everyone, welcome back to the day 44 of our daily leetcode challenge, and today we have got minimum operations to exceed threshold value 2. So in this question they have provided us with an array called nums and a value k. Now let's try to see what they actually want us to do in this question. So from the given array called nums, which they have provided in this, what they want us to do is with each operation you take two values from this array, and you have to take those two values such that they are the least and the second least, meaning the two smallest value. So in this case the least would be 1 and the second least will be 2, or to put it in other words, we have to take the two smallest value from this array, which will be 1 and 2. You have to remove it. So after 1 and 2 is removed from this array, this array looks like this: 11, 10 and 3. Now in this array you have to, again using these two values, form another value, and that value will be formed using this equation they have provided. So if the values popped are x and y, which are the two smallest value which has been popped from this array, the value that we now have to push back in this array will be formulated using this formula they have provided, which is minimum of this value, minimum of these two values x and y multiplied with 2 plus the max between these two values. So the minimum between 1 and 2 is 1, multiply that with 2 plus the maximum between 1 and 2, which is 2. So this becomes 4. So we need to push 4 now in this array. So now our array after the first operation looks like this: 4, 11, 10, 3. Now again we need to take two values from there, the two smallest values, which will be 3 and 4. After doing that, the array will look like this. And then we have to formulate the value which we will be getting from these two using this equation: minimum between 3 4, which is 3, multiplied with 2 plus the maximum between 3 and 4, which is 4, it is 10. Now we add that. So now our array looks like this: 10 and 10. So this is how the operation is happening. In each operation what we are doing is we are popping two values, which are the two smallest values, and then using those two values we use this formula that they have provided to form another value called z, and we push this back to the array. Now this is what a single operation is gonna do. Like, this is what a single operation is gonna look like. Now there's a condition that we have to keep on doing this. You have to keep on doing this kind of operation that we are doing here. We have to keep on doing this until the minimum value, like, or you could say, like, we have to keep doing this operation until all the elements of the array are greater than or equal to k. What does that mean? This means that the smallest value in this, after an operation is done, you need to check. After an operation is done, you need to check if the smallest value in that array is greater than or equal to k. In this value, in this formula that we have, in this example that we started with, 2, 11, 10, 1, 3, the value of k was 10. So after the first operation was done, the array was looking like this, and the smallest value here was 3, and for 3 again it's not greater than or equal to 10. So far we did one operation. Then again we do one more operation, and after doing that we were left with 11, 10, 10. On doing so, we found that the smallest value is 10 now in this array, and it is greater than or equal to 10. So after doing two operations, we can say that we should stop. So this is why we are returning 2. We need to keep on doing this operation. What is an operation? Operation meaning we have to pop two smallest values from this array right here, form a third value using these two values using this formula, and push this new form value to the array. We have to keep doing that until the smallest array, after doing an operation, the smallest value in that array is greater than or equal to k. The moment this happens, you need to stop. So you need to find how many times you did this operation until which the smallest value in the array was greater than or equal to k. So this is what we're gonna have to do. So again, since we are popping two values from this array and then pushing back again values, so there's a push and pop operation happening. So first is we are popping two values from the array, and that to the two smallest, and then whatever value is forming, we are pushing it back. And from this new array in which we just pushed, we are again gonna pop two smallest values. So this is the case where we have to use the data structure called heaps. So how a heap operates is, it keeps values just like a heap is. Like, if you go to a fruit seller, you'll see he'll sort fruits he'll store fruits in the form of a heap, meaning you'll have fruits on the lower section which will have more size, and then as the more as you go on top, the size of the fruit decreases. So this is how an heap operates. The minimum value is on the top, and the smaller and the larger values are at the bottom, meaning this is nothing but a kind of a tree where you will always find the minimum value at the top. That is called as the min heap. So in this question we will be using the concept of min heap, where the smallest value will always be on the top, and if you pop this value, this entire heap will get rearranged so that the next smallest value is now kept on the top. So this will keep on happening until you keep just like you keep popping values, it will keep arranging accordingly. So in this question, what we need to do is convert this entire array to a heap, which can be done using the heapify method, as we discussed in the last question as well. Heapify method will help us to do this. Once we have that, it means that now this nums is not an array but a heap. Then again, the first operation to do is check that if the value at the top, which like once initially nums value is equal to 2, 11, 10, 1, 3. The moment you convert this to a heap, to obtain the value at the top or at the top of the heap, that can be done using nums 0. So before we do anything, what we need to check is, do we even need to do any operation or not? And that can be checked by, after converting this nums array to a heap, we need to check if the value at the heap, at the top of the heap, which will be nothing but the minimum value in this array, right? That's what it would be. If the minimum value in this array, which is now an heap, is greater than or equal to k, in that case we need to do no operations, and we just have to, then in that case we'll just return 0, because that would mean we had to do no operations, because this array was already kind of satisfying the question. Like let's say the value of k is 1 in this array. In that case we need not pop any values and modify them and add it back, in order to make sure that the minimum value in the new modified array it becomes greater than or equal to k. But since this is already satisfied in this question, in this example that we have here, 2, 11, 10, 1, 3, so we need not do that. So that's a small thing we need to do. After creating a heap, we need to check that, and once that is done, we can start doing the operations. So let's try to code this up now. So initially the nums is a normal array, so let's try to convert it back to a heap. So that can be done using the heapify method, as we discussed. Now nums is no longer an array but a heap. Now you need to do a quick check if nums 0, which means the minimum value in this heap, is greater than or equal to k. If that is the case, in that case we just simply need to return 0, meaning no operations is needed, or else we'll store the number of operations that we need to do in count. And now we need to start popping values from this nums, which will be the two smallest, and that can be done using the heap pop method. Now we don't know how many times we'll have to pop, like in each operation we are popping 2 values, and after popping 2 values, make the modification, we are pushing it back, that counts as one operation. Now since we don't know at what point we are gonna get to a point where the minimum value in the heap after doing the operation is greater than or equal to 10, once that is done, we can stop the loop, or we can stop the condition. So it's better to have a while loop, as infinity running while loop starting from while 1. This would mean this while loop will keep on going, and we'll discuss when we need to terminate this loop. We'll see that. So first is I pop 2 values from this heap nums, so that can be done using the heap pop. We are getting the 2 smallest value. Once we have that, the value 3 will be formed using this formula that they have provided. Minimum between these two values multiplied with 2 plus the maximum between these two values. Once we have that, we need to again pop this value back, push this value back to the heap called nums. So this will be done using the heap push method. Now this right here is the new modified. After doing the push, this nums is modified now. We got rid of those 2 values and inserted a third value, and this third value will be added accordingly, meaning the order of the heap won't be disturbed. Meaning if the pushed value is going to be attached exactly at the position where it belongs. Let's say I'm adding a fruit in the between. I cannot add a fruit exactly at the top or at the bottom. I'll have to add it exactly where it belongs. So the heap push method is doing exactly that. Without disturbing the order, it's pushing the value in that heap, so that you will always find the minimum value in this heap at the top only. So because of this, if I go and check num 0, this will provide me with nothing but the minimum value in this just modified heap. So we have to do a check now if num 0 is greater than or equal to k, exactly what we did here. But in this case, we'll have to return count because after doing an operation which is this, we have to increase the value of count. Count gets increased to 1, and once this happens, our loop will get terminated and will be done. So let's try to run this now. So as you can see, it's running all the test cases. Let's try to submit this. So as you can see, it's satisfying all the test cases, and this was it for today everyone. I'll see you in the next one. Bye.